Okay. I'm one of the PhD students under the supervision of Professor Elham Akhavan, and there are another colleague of me, Mustafa Shaban. We don't have it here. We are working together with another PhD student, Mohammad Reza Fakhari, on the area of plug-in electric vehicles. Basically, the focus of our research is in PEVs in smart grid. Today, I'm gonna presenting a brief summary of our research area, which mainly address challenges, impacts, and benefits of the PEVs in the smart grid. Well, I will quickly, we all enjoyed the presentation from the morning. I just want to quickly make a short introduction, and we will take a look at the potential impacts of electric vehicles on the grid, and we'll have a short description of the problem, and we will see some of our solutions as our proposed methods on addressing this area. At the end, we will see some benefits of the electric vehicles as a battery, as available energy on their batteries, and their benefits for smart grids. Well, as we know that the main two main factors of the electric vehicles nowadays, they are very demanding and very attracting nowadays, mainly because of increasing in the emissions and because of the oil price increasing. So the industry investigate new potentials to prevent these two issues. Well, reports mention that the high penetration of electric vehicles is expected in the very near future. And however, if we take a look at our current distribution networks, the studies indicate that the current distribution networks can only support the lower penetration of these huge loads. So it is a time for the electric utilities to start thinking about developing new strategies and plans to tackle the issues, or at least to mitigate the issues due charging electric vehicles. If I want to briefly highlight the impacts of PEVs, we know that they are likely clustered in a certain geographical area, and which will have some significant stress on the part of the grid. Mainly, we can mention the problems such as phase imbalance, harmonics, and other power quality issues, transformer degradation, and also failure due to overloading and overloading the thermal limits, as well as a circuit breaker and a fuse blowouts. Well, mainly if we want to address the overloading issues, taking a look at the statistic of the Manitoba University, we have some predictions that if 10% out of the total percent of the vehicles in Ontario and in Canada will be electric vehicles, and they uncoordinated charging in a worse scenario, which is in the peak demand, we will have a significant amount of additional loading. Like take a look at the Canada case, we have with 10%, it goes to 8.27 gigavolt ampere, followed by 50%, and 100% comes to almost 83 gigavolt ampere, which is really a huge amount of load. And if we take a look at Ontario case, with only 50% penetration of electric vehicles, it will reach to 15 gigavolt ampere, which is, here I have the in-service capacity of the Ontario in 2010, which is almost 20 megawatts. So these additional loads is really comparable with the installed capacity in service. So nowadays, the grid operators and planners explore different solutions to how to tackle plug-in electric vehicles properly, and to how to mitigate their threats to the grid stability. Well, describing the problem simply is how we can accommodate high penetration of electric vehicle in our future smart grids. basically, the reports and the literature studies on this, they address this issue from two different perspectives. The first is the planning alternative, which is mainly they looking at the problem when the owners want to do the charging by their own decision, which is named as uncoordinated charging. For this issue, you know, the owners come home or come to the parking lot and they immediately want to get service. And if the huge amount of electric vehicles, those penetrations want to do it uncoordinatedly, then it will be a lot of additional loads. So the solutions here proposed by different researchers is mainly focus on two different solutions. The first one, as Prof. Salama mentioned for us, is how we can upgrade the existing grid. And the other, well, there is a point here for upgrading the existing grid is that one of our main drivers for the electric vehicles was emission reduction. But if we want to upgrade the grid, it will be some new power plants might need to be installed, and it might shift the emission from one sector to another sector, which we will shift the emission from the transportation sector to the electric sector. So, and by the way, it is a very expensive solution. And another solution is installing distributed generation, allocation properly the distributed generation, mainly new renewable energy sources, in order to tackle this huge amount of load. Another perspective is the operational alternative, which the electric utility always seek for a good, proper strategies and policies to operate, to have a better operational plans. Here, basically, the research is propose smart decision-making strategies, which we will address in our slides. Well, the first, actually our group is working on both alternatives, the uncoordinated, which is the planning alternative, and the operational alternative, because there are two different aspects and no one can say that which one is a better solution. Like electric utilities always seek for both solutions, because both plannings in future horizon and the operational, the online real-time operational issues both of them should be addressed. Our solution here proposed by my colleague, he works on the DG allocation, renewable DG allocation. The solution is a multi-year, multi-objective allocation to accommodate the growth of electric vehicles penetration. The model developed is for uncontrolled charging, and he takes some factors such as month and weekday or weekend and hours of the day to tackle this issue. And also he mentioned the weather effects on this planning, because according to reports for severe weather such as Canada, weather can affect the battery up to 50%. And the research output here is the system cost reduction, which is the cost includes mainly upgrades and losses and distribution system impacts realization, as well as renewable DG penetration increase. The next phase of our study is the coordinated charging, which I mentioned as an operational solution. Although planning alternatives are good, but they reflect the long-term horizons, and when we want to do this study, we need a lot of prospective factors in order to have a feasible result, so that it is good also to have an operational solution, which is a coordinated charging, to minimize the additional cost due to planning solutions. Well, here the studies are focused on scheduling and optimizing the charging patterns for this issue to be addressed. Well, the first studies, the first literature suggests that we shift the charging from the off-peak to from the peak demand hours to the off-peak, which is night. But after that, the studies mentioned that if we shift all the chargings to the night, then it will be a upward pressure on the electricity price, and also it will have a stress on the component, electric component. So nowadays, I can say the recent 2 years, the researchers and also our group we are focusing on smart charging concepts that here for the smart charging concepts, we need an entity work as a medium to communicate between the utility, the electric utility, and the fleet of vehicles, because each individual vehicle cannot communicate, and the owner is not responsible and cannot communicate with the electric utility. So the concept of aggregator here is need to tackle this issue. And aggregator, based on how they have a contract with the utility, they also can make some profit with this contribution. So that mainly the aggregator is a responsible party for making those smart decisions to to propose the charging. Here, our solution, we are assigning a priority to our vehicles. Well, we found that mainly in literature, researchers focus either on the grid constraints or on the vehicle owner constraints or profit. But we found that if we only, as a power grid engineer, if we only want to focus on the grid, then it won't be fair for the vehicle owners. So we are proposing a method that it assign priority to the solution, and this priority is developed in a way that it can satisfy both vehicle owners and the grid operators at the same time. The aggregator will assign the priority. Let's say that we have a parking lot, like 50 vehicles on it, and then they have dynamics of entrance and arrival and departure. So the aggregator should be able to take the decision very quickly and to update the decision after that, because it is an operational issue, and it is, and to be fair for the vehicle owners, they might come whenever and they might departure whenever. So they come, they want to plug in that, and then they need some services, some charges, and they want a departure. So our method, our aggregator we are designing, we actually designed, is possible to make the decision very quickly, like in a very 5 to 10 minutes interval, and then assign and then send the signal of decision, and then get back the result and apply it and update the information right after that, and then do this process again and again. We have a very good facility in our lab, which is a real-time simulator, because it's an operational issue. We really need to make the decision at a real time, and this real-time simulator can simulate every second in a second, so that it is a really good option for us to design this aggregator. Another phase of our study, after we can make an optimum pattern of the charging and smart charging, another phase is to look at the available vehicles as a as a very quick energy sources because of their power electronic interface. They can very quick switch to the grid, so they are a very good potential energy sources to use for some ancillary services. Besides, the statistics shows that these the vehicles are parked almost 90% of the time. So a huge, if we have an aggregation of them, we have a huge amount of battery available, and they can quickly switch to the grid. So we can benefit from the reverse power of them. Literature mainly suppose some ancillary services that is suitable for V2G mode, mainly peak shaving, the regulation, which is voltage or frequency regulation, outage management, renewable power management, and system stability. However, in our research group, our main focus is on 3 of them, which is the peak shaving, the outage management, and system stability. Well, the one thing we are working on it, and again, I want to mention that this is the responsibility of our smart aggregator to tackle, is a conflict. We have a conflict between the ideal vehicle V2G is to serve the grid with vehicles, battery. However, owners are not really responsible for serving the grid. They want to plug their vehicles and they want to charge from the grid, and they don't care it. But the smart aggregator can make the decision and can schedule this charging cycles in a way to be fair for the owner and for the utility. Let's say that we have a parking lot. We have a couple of vehicles. They are they go to work, so like they park for a couple of hours. Their battery are available, so that the aggregator can assign the pattern charging for couple of hours discharge to the grid, and then charge it again, and then make it properly for the owner to departure the parking lot with the whatever charge he needs. So yes, we are in the beginning of the path, and we appreciate all of your helps in this path. I just have a slide of example. This is a very brief result of our scheduling. I just want to show you. Well, just want to quickly compare it. These are 5 vehicles we have and 15 intervals. They are very short intervals. Like we make it 10 intervals. We have 10, 15 intervals. Sorry, we have 15, 10 intervals, and we compare our intelligent proposed method with a first come first serve, very simple methodology. Imagine that we have 5 cars, and according to the grid loading, only 3 out of 5 can be charged in order not to overload the grid. So if the aggregator assigns a simple who first come get first charged, it won't be fair for some of them. For example, if we take a look at here, the 4th EV, he comes at this interval, and because there are 3 other vehicles come first, he might departure at this time without getting any charge, any percent of charge. These numbers here shows the percentage of SOC the battery has. However, if the intelligent method we proposed here tackle this issue, which is like the EV4 comes, and because we assign the priority tackles how much time it remains in the parking lot and how much state of charge it has, and then it assigns priority to charging, so that in couple of intervals the charging might hold for one vehicle, and it might substitute it with another vehicle to get some charge, and then the charging process will continue until their departure. Like the red lines here shows that they are plugged in but not get charged, which means they are holding these intervals. and the red is they are plugged in and they are getting charged. So this was a very quick sample of our result. Sorry for taking your time. Thank you so much.
Any questions for Emma?
I've got a couple. How will the customer let the aggregator know how long they're going to be parked before they leave again?
Yes, they have a smart dashboard. In our let's say in our research, we assign that we have two-way communication infrastructure. So every parking lot has an ID that communicate with the aggregator with that ID, and every plugs has their own ID again to communicate. It shows that which plugin from which parking lot is communicate with the aggregator, and as long as that vehicle plug to that charger, it will communicate with a smart dashboard to the aggregator. It will mention the departure time, and it will mention as well the state of charge. Actually, we are doing some statistic because some emergency might happen for the owner and it might departure sooner. But we don't address it here, but this is another possibility. But basically, like the workers come parked and they stay for a couple of hours. This is or for shopping, they come and like we are using some patterns. We have like how many hours the vehicle owners assign for shopping, how many for working and stuff like that. We are using this for.
So when we're doing programs and roll things out, one of the things we always have to look at is motivation. What's the motivation behind somebody doing something? So what's the motivation for a customer to take us up on a conservation program? And I know it's not part of your statistical analysis of what you're doing, but one of the things you might look at is what's the motivation behind the customer? Why would they want to let somebody know what they're up to, or why would they want to change that pattern? And one of the other ones is you're going to need a communication system. So who's going to pay for that and why? And then the other one is the aggregator. Who's going to pay the aggregator and why?
Okay.
So in part of what you're doing, you may want to look at that and consider some of the issues and
yeah, actually,
why somebody would be motivated to do those different things.
Yeah, actually, for your first question, the motivation of the owners is basically the money. Money talks. Like when they make a contract, they can make a contract with the operators or with the aggregator. It depends on how we design it as a market design. Actually, it is not the focus of our study, but as I know, it is based on the market design. But they will have some contracts that if they hold the charge or if they reverse the charge, they will give some rewards from the like decreasing in their charging rate. This kind of things, and we are considering the price in our simulation. Sorry, I forgot. Oh, for the communication media, actually, for the aggregator, let's say that I think it is a very new topic, and there is still no regulation developed for this, for how to handle this, but. As I see in the reports, the aggregator is working like a third party. It comes to market and it plays the third party role to offer energy to the grid. And this aggregator can make profit or penalize based on his contract.
Sounds very similar to me, like if you're familiar with Rodan Energy and their, with generation assets as well as conservation and aggregating multiple customer client loads, and it's probably easier to implement with fleet customers or corporate customers.
Yeah, corporate. Smart grid, one of the is two-way communication and two-way the contribution, the more contribution of the owners with the utility. We have smart homes nowadays, and the owner, the customers interact with the electric utility to make profit, and this concept is totally the same.
So
research report that said you can, with pricing plans, you can encourage some people to, if people just want to drive up somewhere and charge, they're going to pay a premium price. If they're willing to have their charge delayed, like that flexible plan, there's another price. And then if they're willing to go off peak, they get a cheaper price. But I think you raise a really good point about, from the consumer point of view, already right now, EVs are less convenient than the conventional vehicle. And I think we should be really focused on improving the convenience.
Yeah.
If that market penetration is going to get anywhere close to what you had up on the slide.
Exactly, but let's say something, like when we talk about the owners, one thing is the benefit for the owner, like if what I was asking today about the battery, if they hold, if nothing happened to the battery, then the owner won't have any problem until except he needs the amount of charge when he departs. If the aggregator can satisfy and can make sure that he will departure the parking with that specific amount of energy he needs, it means that he just park his car, go to work, and he didn't know what happened here. The aggregator can make the decision in a way to serve the grid, in a way to not to violate the grid, and then the owner will live without nothing happen for him.